I have no idea if this is working or not, but should be working now. Let's see if the sound is good. Says it's live. Yeah, there. Sound check 1, 2, 3. Can anybody hear? Sound good. Okay. How's the video? Is it working? Всім доброго ранку. Вітаю на каналі. Так. Says everything good, excellent connection, sound is good. And here I am streaming with myself and with Todd, so you can come over here and show yourself.
Hello.
Yeah, there is a little bit of delay.
Oh, there I am. Just part
Yep.
my head.
So this video will be trying to not to break much things and take a look inside of Fluke 9640 and 9610 RF reference sources, and hopefully it will be interesting. So I don't know if the delay is because from my side, or is it actually delayed on the other end. So there is quite a bit of delay. Yep. Okay, let's take a look on the equipment and see what we find. Okay. So both of these are Todd's instrument, so he knows more about them than I do. But we will take them apart, take the pictures for the boards, see what color smoke hides inside of these boxes, and that's about it.
There's two separate boxes. One's a 9640A and the other one's a 9610. And 9610 doesn't really have any online documentation that I've been able to find. As far as I can tell, it must be some sort of military specs version of the 9640A. I've already been inside them once, just to take a quick look around, and they look very identical, close enough. But we'll show them to you when we get the covers off. Now, one of them does not power on with the screen. It does look like it may have power internally, but the screen never boots up, but the other one does. So what we'll do is move some parts around and show you the difference between the self-tests and the failures, and what we can get checked on it.
Yeah, always good to have multiple boxes, which allows to try different boards or modules in different units and isolate the faults or possible issues quicker. So at least that's the hope. So, and I'll be mostly managing the camera and giving different incorrect advices. So that's the idea. That's the plan. Probably this stream will be going for some hours, maybe 3 hours or so. Depends on how it goes. And I'll hopefully have nice photos afterwards with the article sometime in the future, based on these two instruments. And I'll bring the second one in a second. They are fairly heavy, so you have them side by side.
We can take that off.
Yep. Chop chop.
Chop chop. We don't have time for this. eBay labels.
Both of them are eBay special, so the operation condition is unknown, but hopefully self-test will reveal some interesting results. Okay. And there is a question, is the guy a contributor? Well, Todd was helping xDevs since many years, almost 10 years now. And without him, I wouldn't have 3458A for a while longer. So, yeah, we are good friends, and this is our, I think, 5th or 6th meet offline in real life, when we try not to break much of the equipment, fix some stuff, share some calibration experiments and things like that. Actually, right now in the background, I'll show just in a second, we have a bunch of AC voltage metrology going on. So there is a whole setup with those black boxes. Those are thermal converter standards, Fluke 792A, and we are comparing them between each other and testing the 5790 AC voltage calibrator, which is this big box on the bench occupying a lot of space. So we have all that automated and running in background for already almost a week. And while that is going on, we decided to take a look on these RF sources, because I never seen what's inside of them. And there are not, to my knowledge, any teardowns or pictures online on the internet. So we will hopefully correct that soon. Okay, back to the main bench, and I'll be flipping cameras and switching them around from time to time. So,
Okay.
Todd, go for it.
All right, I'll take the first cover off.
And
So I'm gonna figure out how this works. T10.
And I can show some other camera. So that's the camera with the calibration lab. So you can see 792's black units, and they are digitized by 3458A, stacked that near the chamber. And calibrators on top are sourcing AC voltage into the tandems, as well as DC voltage to do the AC-DC transfer. And then that messy, colorful screen you can see in the center, that's the script that I made to automate different ranges, different frequencies.
Okay. So this first unit, the 9640A, based on the Fluke stickers, it was manufactured somewhere around 2010. And right now it's no longer manufactured. They actually have a newer version. I think it's the 96040A, or actually maybe something newer than that. But if you go to their website, it'll tell you which models have replaced it. So,
okay, pretty cool. There are a bunch of wires and RF plumbing around, and boards, like actually big board with the metal shield.
yeah. So we got 2 large transformers in the back. Kind of remind me of the older Datron or WaveTech products. So this one, I believe, may be missing. There looks like there's a shield that goes over the top of this. The other unit has one, but I could never get it to line up properly, so I don't know if it was ever made for this unit or not. But it's very basic. This is the RF board that's on top. That's where all the controls are done from the front. There's very basic cooling, 2 fans that blow across. Really simple air filter, similar to the 5700 series filters. And there isn't a lot to it. Now it's all being held in place by a couple screws, not a lot. You expect to be more in there based on the weight of this board, but to get it out is very simple. So basically you got the support frame in the front here. It just kind of latches in. We have to wiggle it out. It's gonna fight me. The other one.
You need to keep the tongue at the right angle.
Yeah, that's what it says, yeah. So let me start by disconnecting the cables. Now the cables are easy to reattach. There's a very basic label right here telling you where the cables come out from the bottom assembly, which is the power supply assembly, and some other stuff that's going on down there. And it basically tells you where it's going to line up on the upper board. So I'm still going to disconnect the cables. Just give me my hands some room in here to move around.
By the way, if anybody have any issue with the sound or video, let me know. I'll try to address it. Because for me this is also a new setup with a different camera, different computer, and this is kind of a test drive.
Now this unit had some damage to it. The cable that goes into there's a mixer down here. It's hard to see. I don't know if you got the overhead working right now, but there's a middle cable that actually broke out. I think I had ordered a replacement, and it basically comes out of there and connects. I can't remember where it connects on this board. Oh, it connects down there, and it's probably why some of the self-tests are failing.
Yeah.
So
maybe.
I'll have to go grab it. I think it's up in the storage case upstairs. So anyway, so last couple things. C cable. And that cable there.
I think probably I'll take a couple of the pictures maybe after you get the board out.
Okay. Just gotta wiggle it and get it lined up to the slots there in the bottom chassis here, and it'll move backwards out of the way.
Oop. That camera is falling asleep.
There's one. My tongue's still not at the right angle here. 3 hours of me trying to get one. Now slide it back, and just basically provide support for the circuit boards in the front. That's it. And then we got rubber connector in the front, and that's pretty much it on that. So, want to go ahead and take the board out?
Yep.
Okay. Most of the stuff here on this board is hidden. Some diodes off to the side. That's it. And the rear of the board supported by the frame itself has got metal tabs that stick out, and the weight of the board just kind of sits on it in the back. Upper part and lower part. You see some on the bottom. There's some Teledyne relays. Seem to be fairly standard for some scopes and whatever else for our switching.
Yeah, it's pretty cool, like how they did the little cutouts for them. What are those? Those are filters?
I can't tell.
Like a common mode filter choke?
Very possible. Okay.
I was expecting more screws on the shields.
Well, there's more screws. When you see the other unit, the upper shield's got a bunch of screws in it.
Okay.
So probably 20 screws or so that hold the upper shield in. But only 3 that hold the heavy one in. So, all right, and then
Maybe we can move the board over here, and I'll take some.
Take some pictures, and then we can take it apart. It's not that difficult to take it apart.
And what's in there? Just a power supply.
You got the rail, the power supply, and we got some interconnects here from the ribbon cable that go to the front panel, but also under here. And I haven't actually had this apart yet, so we can get some pictures underneath that as well.
That board looks like a kind of lighter dielectric, so it's probably maybe Rogers on top layers for some RF performance.
And one thing to note in here is there's also a low phase noise version of this LPNX. This does not have it, but if you look right down here, it looks
looks like a cutout for the bigger OCXO or something like that.
Right, so if you know what model that goes in there, you might be able to field upgrade it for a lower phase noise performance, if possible. It looks like a 100 megahertz oscillator.
Let's see if I can get that on the top camera. There we go.
I'm going to take some pictures myself. These are the cables, coaxial cables down in here are color coded, so it's easier to put it back together. I also have, it looks like, several test points for the different regulators. So it should be fairly easy to measure different voltages.
Whole battery of capacitors.
Yep.
2 big transformers. Kind of reminds me of Fluke 8508 or the Tron 1281. They also have 2 toroidal transformers for a different reason. I wonder why they have 2 in here.
Gosh. Maybe to balance the weight out because the sucker's so heavy on one side.
And this is the board connectors. This looks like SMB. And then we have one more SMB there. IDC connector and 2 SMAs. As well as that little connector on the side. Nice handy label with the connections between 2 boards.
And you'll notice that that one's labeled 9610A. I've already swapped them for testing purposes.
Good old swapperoo.
Yep, so the one in the other unit's 9640.
Alright. So what we do next?
Right?
Take pictures?
Sure.
Okay, I can flip the camera and actually can show the method how I take pictures. So this was almost never shown before. Secret XDevs technology. Let me flip the camera a little bit around because it needs to be as it does. Little setup time. Maybe stand over here and then I'll get the second camera going. lens, like 110 or 120 millimeter or 105, depends on what camera it is. So we need to get in place. Still the lens. And the method requires to have a tripod and a flashlight, any kind. I'll see if I can actually connect the screen so you could see what's on the camera screen. Let's see that, how that would work. I use just the HDMI capture card. I should see. Oh, I need to flip the setting. Yep. Now you can see what camera I see, or what rather on the LCD screen. So first we position what we want to take a picture. Let's say we want to, for this first shot, get that wire tangle over there with the little oscillator. So I usually set ISO to minimum value. For this camera it's 100. Then f number aperture f11, f14. That's usually a sweet spot for the sharpness and also the depth of field, because if you have wide open like f2.8 or f4, then you would have very shallow depth of field. You would not see much. You can actually probably demonstrate that in here. Here we focus on the OCXO, and with the blinking red you can see the parts that are in focus, but like the part on the in that square shield cutout, it's all blurred out. But if we close down F14 and obviously adjust exposure, then we can see it gets more sharp. So this is zoomed in view. Yeah, I can show both of them at the same time. Yep, so the focus right there. You can see the depth is quite limited at f4. Alright, so we've got our angle, we got our f number. Now we can use the histogram. Use the histogram to get the optimal exposure. And usually it's a good idea to have just slightly underexposed diagram, so you can correct in the post-processing later if you want to get shadows more bright. But if you have too bright of the image, then it would be much more difficult to get even exposure everywhere. So this is about it, and I set the timer. So 10 seconds, auto release. So in this picture, like with my overhead lights, we need 1 second with f14 on ISO 100 to get a shot. Let's take a look how it comes out. So this is like if you just need a quick picture to see where the cables go or something like that. So that's the picture. You can zoom in, take take a look. So not too bad. You can see some marking on the components. Pretty good, but we can do better than that. So let's do the method with the very long exposure compared to this one and without the overhead lights. So for this we will need to turn off all the lights and use flashlight around, and I'll show you just in a second how it looks from the outside. So turn off all the lights, which will be a little bit tricky. It's not a single point. There we go. Hopefully it doesn't fall. Some of the lights off. The purpose of turning off the lights is not to have any constant light, but instead use moving light that I can just wave in the hand. So let's turn off the rest of the lights. I have some lights from the monitor and things like that, but that's fine. And here's the flashlight that I'll be using. It's battery powered, so I can wiggle it around. And right now I can switch back to the camera view if I can find my mouse. Here's my mouse. Just have it in hand. Trackball thing.
You can put it down here when you flipped off lights there.
Oh, here. Okay, so in the camera, right now you cannot see anything because it's too dark. So we need to increase the exposure. Let's say usually I have like 15 seconds, and all the other settings are pretty good. And now if I just put the light on the side, you can see how the shadow moves and how the light moves. So idea is, using the very long exposure, we can keep the light moving around, and this way we can get all the shadows and all the corners lit more evenly, and this would give a much nicer picture. So let's try the settings. 15 seconds and F14. And you can use any light, even like the cell phone flashlight mode. It doesn't matter which light it is. The only difference would be how much of the time and exposure you would need to use this method. And obviously you need a tripod and not to move or shake the camera during the whole duration of the picture. Alright, we got our shot. So this is with the flashlight method, and let's see, this is the previous one. So it doesn't look like much of a difference on this case, but actually, especially like with the labels, we usually can see much better. So this is a picture with the overhead lights. You can see the label on the chips kind of washed out a bit. But with the overhead we can actually see much more dirt on the board, some dust and some spiders maybe. So that's kind of the difference you get. And the benefit of the method with the light, that you don't need like any big studio or expensive 3D kind of multi-light setups, you can just have a little corner in your lab and do this with $5 flashlight from your nearest convenience store. So that's about it. I'll take some more of the pictures and then we can continue with the teardown and taking a closer look on the hardware. Okay, is everybody still with us? So we have 21 viewers and yeah, hopefully sound and everything else is still working. So I'll just take some picture of the cable, different parts. And all of these pictures will be posted on xDevs after we get the article done. That's the idea. And I can see the jump for a bit. And sometimes you get the picture too exposed, overexposed. So if that happens, you sorry, you just adjust the lights or try again with the different settings. It's okay to try multiple times. Doesn't always come out perfect the first time. Another trick is not to walk around the camera too much. So instead of like making a step to the left, step to the right, I more use arms so the tripod don't get extra vibration from the floor, especially on the carpet like I have here. Let's take a picture of the transformer. This takes a little bit extra time compared to the take a picture and go, but I like the results much better. Move it around. So I'll take a look on the fan labels in case somebody needs to replace the fan in future. What people are saying? Any questions?
I think they want your autograph or something, I don't know.
Well, we should all say thank you to Todd for driving for many hours to make this visit, so we could take all these nice pictures.
I'll get some extra questions. know if the monitor on the calibration bench is also driven by the Pi 4? That must be your temperature sensors.
Yes, the temperature sensors are Pi 4. Running with the Python and matplotlib script, reading the Texas Instruments TMP sensors.
And someone else wanted to know how you actually move the light around. I don't know if you actually got a camera angle of you moving the light like that.
We can do that as well. There's a relay in front of the instrument. It's probably for the input or output signal switching. There's the attenuator or some RF, do that over there. So you can check the focus, make sure it's all good. Yep, that should be good enough. Fluke say 6 gigahertz or no, that's probably the part number. And I think actually the cable is cut off or broken.
You're right. I need a replacement cable for that. I'll probably steal it out of the other one, just so we can run the self-tests.
Oh, it's actually the cable that goes to the front SMA connector.
Correct.
Well, we don't need that. Who needs the output, right?
Extra cables.
I think with the frequency this low, probably any like decent quality SMA jump cable would be working just fine. Like Shariar would say, it's pretty much almost DC. These instruments go only to 4 gigahertz.
4 gigahertz.
Yeah. What else can we capture? I think we got pretty much most from this angle, and that's about it. So I usually try to get like angle like on the sides more, and visually you can also see like where you get the reflection. So you don't want to have 90-degree angle to the lens on the shiny objects, because then you will just get a glare from the flashlight. So the trick is kind of to avoid that position and wave around somewhere else. What is this PCB on the back? Is it the power supply stuff?
It's part of the GPID.
Well, there are a bunch of big inductors and things like that. It's hard to see behind the metal work. I see 2 capacitors in there. And some common mode chokes. I think that's the main power supply there.
Maybe digital power supply.
Yep. Yeah, here a little bit dark, so let's try again. So like if we shine the light right over there, we can get as much light between those shields as possible instead of like going from the side. Yep. So I guess we can go to the next step, maybe. Let's get the lights back on. And move the camera out of the way. think I'll need to use this one. Huh? We can flip the cable. There we go. Back in business. All right, let's go.
Okay. Let's start by. I can take this apart. Or you want to?
Up to you. You decide. You the boss.
Okay. I'm the boss. All right. Let's start with this.
Yeah, it's winter time, so we don't want to zap RF things. Hopefully. Is the audio okay? Everybody can hear both of us? Because I have just one microphone near the camera. Sound check, 1, 2, 3. Still very cold where you are? Not really. It will be plus 20 next week. I was hoping for a little snow one last time, but seems like my hopes are unfounded.
Okay.
I think we will probably need a little bit more light, so I can do that in a second. That's better. We had snow in April here in Kansas before. Give it a second, I'll take one shot.
Okay.
With all the screws standing.
Stand in attention.
Yep. We're good.
Okay. That's another bottom.
Do you need like a pry bar?
Pry driver.
have an angle grinder.
J-bar will probably be fine.
Use maybe
Really tiny one? Yeah.
probably not that tiny enough.
Yeah, that works. Maybe screaming out there. No.
Maybe this one. This one is thinner. Easier to go between.
No, I got the other one apart.
If it doesn't open, just apply more force.
That's right. Or buy another 9640A. Feel a gasket material or something. I want to go up there. You can feel it.
Well, it
Start
doesn't
pulling
really
apart.
want to.
Yeah, well. You can hear it separating from the. I feel like it's gasket. Maybe RF gasket. There you go.
This board also looks like maybe Rogers on top, so we should take a picture later of the side of the board to see if it's actually all the board Rogers or just outer layers, as they usually do to save some cost. Ta-da! Oh, that's pretty.
Mm-hmm. Pretty expensive.
Yep, that's a good spot.
All right.
So let's take a closer look, I guess. Camera 1 to camera 2. There we go. And let's see what we can see from the obvious things. I wish our friend from Signal Path would be here. He would say, well, this is doing that, that and that. Very easy and straightforward. That little thing look pretty fancy there, with surrounded with the bolts. Probably something important. So we got octal FPGA, some interesting symmetrical layout thingies, linear technologies chips, probably DACs or ADCs. What else we got here? ESD don't toucha. Some relays on every section. Oh wow, that's pretty. Somebody didn't clean the flux around the regulator. So quite pretty. Do they have a marker how many layers are there? Usually like it's somewhere on the corner, maybe like here or there. And doesn't look like. guess we can snap a couple of the quick pictures, or maybe even do the little video. Let's see. Little thermal pads to help with the heat sinking on the hot parts. That area right now looks like a bunch of different filters, a lot of inductors or capacitors with some relays to select which filter to use. Alright, so what else we can do? What's about the other side of the board? Is there anything going to fall off if we turn it upside down?
I don't think so. You can see the relays are going to be on the other side. You have to take the screws out.
Will they fall out? I think they are mounted to something.
Yeah, they're mounted
Oh,
to the back
okay.
side. You can see the circular pads where the relays are soldered.
Well, I guess we can take a picture of the board overall, and because this lens is 120mm, it's quite long. I think we will need to take the cover, put on the floor
Right.
with the board on it, and then I'll just have a shot straight down. That probably would be the easiest to do. So you just put the board sideways like that. Yep. If it fit, should fit.
I think so. If so, we're world of hurt.
Yep. Little sketch, but alright. Hurt position stuff. This would be actually a perfect example of the benefits with long exposure waving hands with the light compared to the just overhead lights, because we have a big glare from the light straight up in the ceiling, and obviously we can easily fix that glare by the moving light method. So we can do both of the pictures. So we can do the focus, make sure everything is nice. I actually need to move the camera a little bit. So it's important to have camera as parallel as possible. Otherwise you would have some of the areas of the PCB sharp, but others not. And something like that. So this camera have the feature that shows you with that red outline where your focus is. Quite handy. Obviously the final picture would not have any of those red outlines. And that's about it. And we can use the ISO 100, f11, and The trickery, first we can take a picture like it is with the timer, and this actually needs to be off. There we go. You can see a lot of glare on the left side, and I bet a lot of the component markings would be all washed out. So let's zoom in and check. So the painted ones you can actually see pretty nice, but others, well, not so much. Like that chip between the two capacitors, you would have no idea what's written on it. But the sharpness, oh, there is a botch capacitor next to that relay, probably factory botch. Nobody bothered to clean the flux around the relays because they probably were soldered by hand. Some more bodges in here around the DG211. So let's do the trickery. F14, F15, F11 shutter speed 15 seconds, should be enough. And now I will just apply the light from the sides close to the floor and go all the way around a few times. Okay, that's a little bit too much light. Let's do 10 seconds or 8. And I'll switch to the webcam in next shots, so you could see how exactly I'm waving stuff around. Okay, that looks better. Spot. Mouse. Yep. So, going to show exactly the movement. Sorry to coordinate everything in multiple hands. And I think we got the picture. Results. Still a little bit overexposed, but let's go to that capacitor and the chip. Yep, we can now clearly see as it's C46M2451 ACMC, I guess. take a couple more shots, and then we can. Oh, little botch right there. Oh, is that blown, or is it just flux? See that? Looks like something's blown. Need to investigate that area closer.
Yeah.
Maybe it's just dirty flux.
Another one compared to.
There's another picture, a different light. And this was with the overhead lights, so you could clearly see the difference. All right. Any questions in the chat box? Everybody sleeping already?
Somebody came in and wanted to know if it was the 10A or the 40A, but actually we have one of each. The one we're looking at now is a 40A, but it's got the 10A board that we've got torn apart, so mix and match right now.
This is a really nice picture. Put the light more uniform. And usually I just zoom in a couple spots to make sure everything is sharp. So like, because sometimes the camera get moved or some other accident. And with the dents or repairs like this, where you have a lot of things to unscrew and screw back, you don't want to take it apart again if you miss a picture later. You can also take a couple of the closer shots with the camera more close to the PCB. Taking nice pictures takes quite a bit of time, and that's why documenting stuff and making nice articles, it's a lot of work.
You want to know why you're holding the light closer to the floor than above it?
What's the question again?
The question is, are you holding it close to the floor for a specific reason versus being like overhead of it, or the angles of the light to the object you're
Well, the reason for the closer to the floor, the main one, so you get all those chip markings to come up much more contrasty. Because if I would have a bigger angle, then I would have more glare from the PCB. But from the very small angle, you mostly get sideways light across. So it just have more contrast. But I would encourage to try either way, because all you losing is just a little bit of time. And if you don't like particular lighting, how it come out on the shot, I'll just try another way. There is no like correct or incorrect way. Whatever way works best for you, that is good enough. Especially if there is like something shiny, like metal shields or stuff like that, then optimal angles can be not obvious to find at the first try. And then if there are like tall capacitors like electrolytes and things like that, or like some through-hole parts with the marking on the side, I usually try to take like a picture of those as well separately, and not just like top and bottom view of the board, because on the sideway parts you wouldn't see the label or the marking otherwise. Okay. And if you do like this would be very bad. So you could see like a lot of glare from that angle. So I avoid that particular position and wave everywhere else but there. Alright, I like how the gold came out on that one. Let's try again. And also for the pictures like this with the tripod and camera in static position, it's important to disable or turn off vibration reduction or optical stabilization if your lens or camera has that function, because it may get confused with the moving lights and try to move the sensor, and that would just result in a blurred mess. So that's a important thing. Like if you have a camera not moving, object not moving, then vibration reduction or optical stabilization functions, they should be off. Okay. Let's see if we can get the... I want to have that shot with a board stack. Let's see if I can do that. And also I usually do the manual focusing for all my static pictures, so I would know that the focus point would not change when I'm messing with the settings or parameters. Well, that should be pretty decent. Let's see. Closer. Enhance.
Close up.
That's something. I think this is pretty good.
You can try polarizer lens on camera and polarized light.
Well, I do have a CPL on the lens, but I don't have the polarized light. That's actually an interesting idea.
And Vietnam says hi.
Well, hello to Vietnam. Okay, is there any interesting 3D parts we can take a picture of? Ah, interesting.
No V-shaped resistors or
But like that, the part with the
black spot.
thermal tape or thermal pad on it,
Uh-huh.
looks like some business going on over there.
Ceramic. Is that a ceramic part?
Let's see. Yeah, it looks like ceramic. You can see how even on, so this is F4. Change the, so F4 setting. How much depth of the sharpness we get, and then if we change to F16, how much wider we got. Still quite blurred, so for this picture we would need to use the focus stacking. So that's when you take multiple pictures together with a slightly different focus between each of them, and then in the Python script you can combine multiple of those pictures into one nice sharp picture. That's a very popular technique in microscopy and macro photography. Pretty much almost the only way to get very nice, sharp, uniform images. But the drawback of the focus stacking is that you need to have same light on every picture. That's why the waving light like a maniac around the camera would not work well. So we can do one stacking here, maybe a little bit taller. There is actually an X on one of those. You see it?
Yeah.
X.
Shout out to xDevs.
X chip. So let's do the focus stack. This camera have a nice feature. You can set from where to which point focus point A, and then you select focus point B, and it will calculate and move the focus on the lens all automatically for you, and take all of those pictures in between. Super handy. Would you need a complete complicated multi-source setup anyway if you work with polarized light. I don't know, I'll try it. MMICs, maybe MMICs. I have not much experience with RF because that's not what I use in my daily life.
TSP place, isn't it?
Yeah, we need to have help from Shariar for that. And right now focus stacking is taking a lot of images. We can see the counter. So right now we are on image 41 from 105. So there will be 105 total pictures to combine from. And this camera generates about 200 megabytes per each of those pictures. So quite a lot of space need to be used for the processing like that.
What kind of medium is it being stored on?
It's SD AXE card. I think 256 gigs in that camera. And it's actually struggling because I was too cheap to buy fancy fast cards, which they can go pretty high in price, you know, like multiple hundreds for the 256 gigabyte card. And I decided I can wait a little bit to buffer down.
The one time xDevs decides not to overpay.
Yep. And then buy 3 more cards because running out of the space. Is Europe still sleeping? So that's kind of the setup. We can record some video and process as well later. Okay, we're done.
Clickety-clack.
And there are a couple of the budgets. Maybe I'll get a few of those and we can move on. There's a bunch jump wire and some vertical 3D mounted transistor. So we can do the same thing. From there perhaps to right here.
Compare the revision of this board to the other board.
Yep. What? Just one? Just use that a little bit fasten up the thing. Are we going to take the shield from the backside too? Do you want to?
Can.
Can switch the camera to the looking taut.
Yep.
Looking sharp. What time is it now? Is it 10 or 9?
No. It is. I can't tell.
So pictures are picturing.
10:20. 10:20 Eastern.
And the experiments that are running over there. So this is 5790, calibrating from 792A. And there are 2 other 792As comparing each other. And the calibrator sources over there. And then you can see Todd brought some resistors, Fluke 742As, that we are comparing inside of that thermal chamber using a resistance bridge that is hiding right in the corner over there. And the reference resistors are sitting in that chamber, big one with a tiny one. And the script is running from the Raspberry Pi on that screen. Okay. I guess you can take the screws out.
All right.
Oh, sorry.
12 more screws. Where was the area that you thought had damage to it?
Here. To take a look up there on
Yeah,
the
with a
microscope.
microscope, yeah.
Okay, my time to chill.
Drink some tea.
Yep, I need it. Hello, NDP. What is Magic Lantern? I have no idea. The camera I use is Fujifilm GFX.
I think he's asking about the GVM there.
Yeah, the light I'm using is GVM 560 AS, but I have it just only because I wanted to do some videos, and it's adjustable 30 watt LED light with a white balance adjustment. It comes as a set of two lights with a tripod thingies and optional battery. It's a little bit heavy to be waving around for this long exposure business. So your hand gets a little bit sore after doing this for a couple hours. Is it late 10 a.m. or 4 a.m.? 10 a.m. 4 a.m.? Oh, okay. I think Todd already answered that question.
Make sure all the screws are the same length. On the 5700A, they love mixing and matching different lengths. Right.
Really?
Depending on how many layers it was going through. Through the back of the main board on the back. Like
Okay.
3 different length screws or whatever they use to take the whole thing apart.
But usually, like, I think they use the same one for the shield one, and then shorter ones for the outside of the shield.
Yeah, I think maybe 1 or 2 exceptions, but yeah. Okay. This is where it gets a little tricky about flexing the stupid board. I'm not sure what that's for.
There's probably some tall parts in that area. I have.
Yeah, it looks like there's more relays on the back side that might be hidden.
little of the
What else?
soft pad that you can put the board on.
Right.
Which supposedly ESD safe.
Supposedly. Those are the last sort of screws.
Apply more force.
Yep. And everything falls apart and all these bits fall out, screws and springs and
Probably flip the lens to another one. Oh, you're taking that box apart?
Huh?
Taking
well, I
the,
figured that we're gonna take all the screws out. There's probably something else hidden under that we need to see. Maybe.
I was thinking that little box is mounted to the main shield.
Right.
At least that's what I would engineer it for, like that. Wow.
Ooh, square parts. Square relays.
Square, round, all kinds.
It is interesting to see though.
Well, you had the square box, so square relays.
Yeah.
Makes sense. You maybe like put the board standing vertically and then you can pry easily. Maybe.
Just trying to get a little bit underneath. It's too much force. There you go. Popping that first cold beer.
A lot of turning around over there.
I'm sure somebody at Fluke right now is going to watch the video and go, oh my goodness.
Did you pull all the screws that go through the board from the top?
Yes.
I think there are no more screws, like all of them come from the shield. Or are they? What about those screws on the board? Like 4 screws around the chip and some other area?
Yeah, we took those out. That's what holds the bottom plate on. Besides the other ones that we took out.
Okay. Well. When you hear a crack, then you know.
That's it. Calibrated crack. feel like I got most of it around the edges, but it's still the center part of the board.
Scary.
I know.
To move a screwdriver all the way in like that.
Blind.
Like, if there are like little SMDs there, then they all go bust.
What are these little chippy things going floating around in there?
Wow.
Yeah, it's a lot of force. Just gotta be patient.
So there are no parts on the back?
There's gotta be something on the back, right?
Well, you are like putting the screwdriver kind of bravely, I would
Yep.
say.
Yep. There we go.
Ta-da!
All right, let's put it back together. It's not want to see what I.
Only
Hot
took
dog.
1.5 hours to get to this point.
Yeah.
Okay, so there are not much parts. Oh, pretty shiny.
Yeah. Isn't pretty?
Making the camera crazy
Yeah.
because of all the overexposure. Cool.
Yeah. Well, that RF gasket material kept sticking. Was it worth it?
There are little pockets with the thermal grease in there. And I
Yeah.
guess there are bumps on the on the CNC.
We might have to re-grease it before we put it back together. You can see some heat where it's gotten warm right over here.
Wow, look at that soldering job. Somebody went medieval on it. Let's see. I think I'll need to put a long lens and get some more beauty shots. I was expecting to see some parts and components in here, but no, just some of the through-hole stuff, and this probably LC or just L filters, like those common mode chokes you often see on different boards. Pretty cool. Let's take a couple pictures.
If FF join us, Steve?
I don't know.
He's out being chased by owls tonight.
So there are process ongoing. Ouch. And probably for this one, because it doesn't have any chips, we'll just take a picture with the board against something, and that would be it, and we can move on to the other unit finally. Right?
Yeah. Well, should we take the bottom board out?
Oh, okay.
I haven't had that one out yet.
We can do that as well. Just the right prop. Talking about the props. So this is, since we are repairing or rather tearing down Fluke equipment, this is a transformer from Fluke 335 calibrator. This is a 1000 volt high voltage transformer. It's quite hefty. Was donated to the channel long time ago, and it's great when you need something heavy. It doesn't move much. Yeah. Too many tripods. To do a small focus stack. I think the polarizer in this case would help. Maybe not really. Okay. Just 6 pictures. Part number? No, it's on the side. Sneaky.
I think they're the same part number as the other one.
Sleeping yet?
Nope.
Let's reposition there. Once a bit. Looks like it's board was 2007, 2008, I guess.
Interesting to see if the 9610AF add the low phase noise oscillator, since the government likes to spend the extra money on stuff. All the bells and whistles.
Label is quite faint and hard to see. No, it's just protective film. But it bent the wrong way. I guess you probably could leave that cap on the other side on, because it doesn't go to the board. Okay.
On to the next board. Okay, there you go. All right. Power connectors. Then we could screws that and everything out of the way.
I think the 792 is finished. Because nothing is happening over there.
Pretty get quiet.
Yeah. Let's see what's going on. So you have repairs written in the title. Is there something wrong with the units? Yes, the self-test fails in one of them, and when they're mixing and matching boards, other one got to pass the self-test at some point. So kind of trying to find out which board is bad.
We knew another one fails one of the ranges. Second or third range maybe. It was in the description somewhere. That actually failed a specific self-test when I was running it, so it wasn't anything different from this what they advertised in the auction than what I found. I haven't replaced any parts yet for it. Alright.
Let's see the scripts. So this is the script for resistance transfers. Right now it's running calibration between 10 ohm and 1 ohm. And actual resistance bridge. I can kinda get, yep, right there.
Thanks.
Difficult to get the right angle because it's all automated. So I don't have much access.
Slide it over and out. Clear the tabs. What's that? That was easy.
Mm-hmm. We can blow some dust off.
Yeah.
We have a compressor, so. Why do you have two oscillators?
Good question. 10 megahertz for.
Not important one, an important one. I might have actually one of the oscillators. Probably not this, but the one that they use in HP 53 counters.
Right. Yep. I think I've got one or two myself. Okay. So. I'll give you that. Set it back on top of this. Alright. Don't put anything on top of that. Alright.
Patient number 2.
Yep. Oh. Dusty.
EDR 1001.
I seen that, yeah, but there was a 2 on the end.
Actually, ARD.
Alright. So the reason it's probably failing those 8 self-tests because I don't think the cable was broken when I first got it.
Mm.
But when I moved the cable, or when I moved, I think, swapped them, the upper things, the cable pulled out. Because I didn't put any force on it. Alright. So anyway, me take pictures of it as it is before I pull the lid off?
No, I think you can go ahead.
Let's see if there's anything on the bottom. Nope. Oh, bodge wire. Ooh, bodge wire and a transistor. Or a diode, one of those. Alright, that's worth a picture. You have like a brush or something like that for dusting, or not? Just, yeah. Yep. That's, I can use that. Maybe you got like a paintbrush or something for dusting.
Not quickly.
You got everything but. Alright.
It will just take you a while.
Take me a year
Like
to
those-
dust it.
People who
Oh,
do
the archaeologists?
ancient- yeah.
Archaeologists. Somebody shows up with a canned air or whatever. You don't have time
Well,
for
I have a
this.
compressor, so we can just run that. So the camera out. Far away. There we go. I think I'll need to mute for a second because compressor quite loud.
Okay.
Get the sound back on. 1, 2, 3. Yep. Yep.
That's the secret to xDevs, all their work.
It's quite a bit of stuff for the power supply board.
Yeah.
Micro to. It is cheap.
See if they can hear the compressor.
This board looks prettier because of the contrast between the
Right.
faces.
You turn the compressor off or just leave it on. Looks like the same controller, right? Hecto. Oh. Micronetics. Anyway.
By the time we get to the repair part, it will be already morning.
Yeah. What repair? We're supposed to repair this now?
Ow. It's painful.
Dangerous. Landmine around here. Minefield.
Whoop. Microscope is in the way. How high in the voltage these boxes go? 100 volts? Can I do
I don't know. It's a 50 ohm source, so probably not very high.
that? Okay. Though maybe like for the lower frequency they can go higher.
Maybe, I don't know.
Because that power supply looks quite elaborate. A lot of something there. We will need to do the trick again with the floor.
Yep. It says, I think it does up to 30 dBm.
Okay. Probably confused with something else.
Yeah. You want to smoke too many power
I think
sensors.
maybe like the 9500 calibrators.
Yeah.
Those probably can go pretty
They're
high.
mostly for scopes, yeah.
That should do it.
Oh. 96270A. Now he's bragging. 20 plus 20 dB unlimited free.
99.
Thermal paste.
Micronetics.
Micronetics. It's like some sort of transformer.
MCL B941. ADE 12MH. RF thing. Bunch of these ones. Oh, LT2440. That's the ADC.
No LTZ 1000s, huh?
Nope.
Send it back.
Cool. Go next.
Nothing obviously wrong with the board. It's not as dense
No,
as
at
the
least
other
not
one.
visually.
That's good. Alright. There's only like 2 screws that hold it to the back. But it's probably just like the other one. There's nothing on the back side.
Point light source or big diffused light source better for this technique? It doesn't actually matter. Actually, diffused a little bit better, but it doesn't really matter. You can have equally good result with any light.
Is do we put it all the way back together again, or we just open up the other one?
Probably open up the other one.
Okay.
We can use this table maybe.
So you got this cover on here, but there's nothing underneath it.
I can put like a.
Maybe
you
there's
can
some sort
put
of test
on
points?
the box. Oh, you mean the bottom?
Yeah, this. I mean, there's when you take it out,
Well, that looks like some chip supposed to be here, maybe.
right? Or maybe some test points, or they test it before they stop.
That.
Okay.
And I guess I'll look what the scripts are doing for the 792.8 calibrations. Okay, so 5790 finished.
Okay. Actually, put that in there. So this is the chassis for the 9610 A/AF. Cover's a little harder to take off because the handles are in there. This won't catch. Now it's clear. Alright. Well, one came with a shield, the other one didn't. Normally there are a lot more screws in here, but I had already been in here swapping boards, so I only put a few of them back so I could transport this. There's also a bunch of screws along the sides as well that are not there.
Just fix this.
Yeah, just get in the way.
Alright, meanwhile I'll reconfigure 792.8 for 1 kilovolt test.
Uh-oh. Smoke test.
So for 1 kilovolt we need to configure the transfer unit to 2.2 volts and then add attenuator in front of the transfer unit. Show the Jansky?
Almost.
Space horizontally. You checked it, right? It's good.
No, I didn't check it. I thought we ran it the last time we were here.
I don't think so.
We'll do a quick home check on it, right?
Yes.
We'll never buy anything broken off the eBay. Not including what I'm touching right now.
The most stable ever digital multimeter. Never
Slash
drifts.
calibrator.
Kilos ish. Little vary.
World's most famous 792A.
That's about it.
Here we go. Magically, all the screws have been removed. And this is one that has a cover on it. That's only an extra step. The board looks identical compared to the other one on the 96. Well, this is actually the yeah. These are the errors that were found or advertised during the auction. And this is actually the 9640 board sitting in the 9610. One thing you'll notice, look down at it, the cutout on the bottom board, it does not exist for the larger oscillator.
Uh-oh.
Yep. So it's the cheaper model. The Air Force went with the cheaper model. Not the,
Isn't the board a little shorter?
oh, you didn't need a microscope, did you? The board looks about the same size.
Really?
Yeah. You don't need a microscope.
There is the section sticking out there,
Yeah.
but not here.
Yep. But it says good and Sharpie, so it must be a good board. All right.
The setup with the kilovolt dividers for AC voltage. Where are the leveling heads?
Oh, don't even bother. Don't start. They're somewhere.
They are back at home.
They're somewhere. Alright. They were bought secondhand. I didn't buy them with the unit, so this unit's not even calibrated with it. All right.
Now it's just running the ACAL.
So the part number on the 9610 board is a 401622-2. Looks like a .10. That may be a Rev 10. And then the one on the 9640 board is 401622-2.9. May not be rev difference, who knows? Let's see. Oh, didn't do that.
No, you don't.
No, you don't. No. Markings on the board seem to be identical, just slightly different part numbers. Four 14077-2. This one apart. I think I've already got this one out. Yep, because the screws are still loose. And this one has the error somewhere in the 1.8 gig to 2.7 gig range. And the self-test actually specifies that. Still see some bodge wires here.
Same stuff.
Yeah, looks like it. Some bodges right there. No black spot right there. That's a good sign for this board.
This looks like an inductor, but there is the metal
Right.
spec. Like a ball of solder. We can take a picture later. There's no point to remove the backside.
Nope.
It's pretty cool. They have the via holes around the relay pins
Mm-hmm.
for better like isolation. Maybe the like little bit less capacitance. Kind of neat. You see that before?
Alright. What do you want to do next?
Let me reconfigure stuff here real quick. On this particular board, there's also a known issue. This connector right here, the center pin cable, actually broke off inside there. So unless I can remove it, I'll have to replace the connector if possible. So it actually prevents this board from being tested any further until we can get that fixed with this board. But basically with this unit, it doesn't power up on the display. So that's why I swapped boards. I moved the board that used to be in here to see if it was actually good. Moved it over here, and that's where actually this one came up and ran self-tests. And now that I got a bad cable on this one, that's probably why it's failing, I believe, 8 tests. So basically what we have to do is steal the blue cable out of here, which goes to, I think it goes to the front connector. I don't know if that actually really makes a difference with it missing. But there's also one other thing here, Ilya, is the bottom board does not have the SMA connector on it. So maybe this is an option for something else. Maybe external signal source or output. It doesn't seem to be needed.
Could be an adjustment too.
Right.
Check and see over here. Somebody's getting deported. Not me. Alright, yeah, there's definitely some differences here. Don't see anything physically wrong with it. Let's see if I can zoom in on some of this. TC 1668. DG211s. Micro MIC 5841Bs. They're drivers. Relays or something? I don't know. Analog devices 8512A. More digital switches. 512A. Seem to be all over the place. More hard to decipher. H346, BP15. All right. What's next?
Take photo. So you want to install different boards?
Well, I think I got the boards that are in there to where they're supposed to be in there.
Like good with the good.
Yeah, sort of. I'd have to put. That one definitely fails.
Does this one have X on the thermal pad?
No, I don't think so. Probably why it failed.
What time is it?
That one says 10:42, but I thought that one was an hour ahead, like 11:42. What does the clock say behind you on your display?
11:42.
Okay.
There's one on Chicago timeline.
Hmm.
Okay.
All right.
Oop.
Then we work again.
Don't smash into things.
This guy smashed into your microscope earlier, you don't know it. So now we're even.
Nice. So then we will try to power it on.
Yeah, I'll start reconnecting the cables and tighten all the boards back together. So clean it up a little bit. Okay. No, this one doesn't work on wire back. Wire. This one's slightly different.
See some juice there. Make you extra sneezy.
Yeah.
I wonder where the calibration is stored.
Good question. The front panel. Torque wrench. Alright, we're going to put this back together. Do the same with the other, and power the other one up. That's supposed to happen. Alright. Oh, that's it. This one's pop right there. I didn't even actually see anything from the front panel, but I guess not. It's all hidden away. So that broken cable is what goes to the front panel. So that's the one that powers up. That's the one that actually turns on. You want to get pictures of one of them working, or?
I thought this one.
No, this one's the lead key. I'll just throw the covers for the screws back in. This one goes in that one anyway.
Battery 1 is dead.
No, is it already?
No,
Yeah.
there are 2 batteries. They knew it. touchscreen?
I don't think so.
The most quiet live stream right now.
Yep. running a record yet or what?
Hmm?
You're running a record on this? Longest xDevs video?
No,
Not even close?
not even close.
Oh.
I think FX reference layout was like 9 hours.
9 hours? Did anybody make it all the way through from beginning to end?
It was part 3. Previous was like 7 or 8.
Jeez. If people are interested, I'll put them to sleep.
Nobody commented on it.
Really?
It's not like
Zero count.
Is anybody still watching? Everyone just asleep. Yep. It's about that time here. The top camera goes to sleep after.
Missing leftover screws. Right, fly it up. Alright. People still watching? Alright. Lucky 13.
If everybody's quiet,
And they're probably drunk by now. It's Friday night.
nobody's asking anything.
It's a bourbon
Nobody's
night.
saying anything.
People taking bets to see if I get electrocuted.
Fancy tables with spooky wines. Are these originals?
No, I ordered those and they're the wrong kind.
What?
They're supposed to be male to female or male to male? No? Oh no, they're right. They're right. I bought it so it fit through the front panel. So maybe it is the right one. questions and RF comments? Big shout out. Send me some free cables, please.
You heard it. Get in touch.
Yeah, actually, that cable actually might work. Look, so alright. That's done, that's done, that's done. This one. There is something weird about this. It is. It's probably why it's failing. If you look at this one, the switch, the RF switch that's on here, each of the cables has an attenuator in it. I have to pop that cover back off again. Look at this cable. It's got an attenuator in it. Comes out. And what's at the other end? Another attenuator. It's not supposed to be like that. Pull the cover off on this. I know, those handles need to come off. I'd rather put the handles on the front. It's easier to carry that way.
Maybe one is not attenuated, something else? Look, DC block or
DC block maybe? Oh well. They're both like that, so they gotta be right. My eyes are playing tricks on me. I could have sworn one had. What? 1.5 of G6, G2, And the other thing I thought when I got it was that these cables are crossed. One went to one side and the other one went to the other side, but that could explain why maybe the part's fried. So we got the input power way too high. all wired up except for the front panel. Looks good. I think this one will fit in there. So this cutout right here is how thin this cutout is. And that filter, it just doesn't line up with it. All right. What everybody's not been waiting for. You want to do the honors? No?
Gotta capture the magic moment when the smoke escapes.
No, the smoke will come out this side. I'm going to stand over there. Wait a minute. Here, hold my beer. Uh-oh. There we go.
Go for it.
And the display isn't very contrasty. You want to turn the lights down a little bit, or? It's not much better than that 50 is the super thermometer 1590 or whatever.
Ouch.
Crappy display. When it works. Okay.
Yeah. Let's see it.
All right.
$18 watts.
Yeah. Can you barely see it? There you go.
So does the self-test on power up?
Yep. And how many years? 8. That's what I had before I brought it down here. Oh. It's even better. Only one failed. Except before, I'm pretty sure that I had all the tests pass at one point. You could probably just let it run for a while and see after a 30-minute warm-up if it'll pass the self-test.
So it's about 100 watts. power consumption. 105 watts. 120 watts. Carrier level duct, some value nominal 0, limits measured, well, almost 1 or 2%. I like the font, nice and big.
Alright. We just let it sit and warm up today.
It's pretty quick.
Better than the 8588? No? Yes?
It's more lively.
It's like the, what is it, the 4900? No. What's the calibrator that I got? The old clunky one. The Wave Tech. No, it's not 4900. It's the equivalent to the 5500. No Wave Tech made. Oh? Is it too late for me to be challenging your memory and all the models?
0 failed.
See? Just to warm up. Maybe get some to do with the oscillator or something like that.
We fixed it.
Yep. Had to get a bigger hammer. Now the other unit doesn't pop, the display doesn't come up, so.
Brain's dead.
Or that we can swap the front panels. That'd be another test. But I'd be willing to bet the front panel will probably come up.
So I guess you can replace the cable.
Yeah.
Maybe
it's long
tomorrow.
enough. Huh?
Maybe tomorrow.
Yeah. If the cable's long enough, I just guesstimated how long the original was. It's a chatterbox, isn't it? Oh, all right. Now, if somebody had remembered to bring the heads, we could see if the heads passed. So unreliable. Sitting with the camera, probably.
I had one job.
Yep.
I like how responsive it is. So much faster than 5730. Enhanced. I like the sound of that.
Yep.
It's a lot of digits.
Yep. Some guy named Igor said he's going to sleep. See you tomorrow.
I actually quite like the UI, how they made it.
Somebody says EVGA Dark died for this.
Nice and quick. I like it. display is much better than the
1590.
1590, yeah. Ooh, different colors.
Oh, really? That's fancy.
Let's go all the way to the TV guards.
Should, yeah.
Yeah. 1 millihertz.
Alright, that's good for calibration of the Keithley 2002, right? Needs some millihertz?
1 hertz.
Just 1 hertz. I'm disappointed. Oh, DEFCON posted. Says that we're missing the live stream.
Head not fitted. Output cannot be turned on.
Okay. It doesn't just want you to spew out RF everywhere and just fill up the case with RF. Alright. Somebody, that'll be like part 2, right? Part 2. Someone will ship you the heads when they find them.
Sure.
It'll be an exchange, right? I'll send you the heads and you send me my computer when it eventually ships up.
We have a tradition. Every time Todd comes to xDevs, he orders something and it never gets shipped or gets shipped too late. And then I have extra stuff. Shows up at the doorstep unexpectedly. So I guess that's about it for us for this time.
Yep.
And be sure to check xDevs.com for the pictures and upcoming article.
Work on repairing the other one.
Yep.
Seems to be common. I've seen a bunch of the 9610s or 9640s sold without a working front panel display. And that's actually how I got the one that's not working, but there were several others that were also in the same condition. So once we figure that out, at least there may be a common issue among this model.
All right. So I think we will shut down this party, and if somebody likes this live stream and want to see more of it, well, you can always donate to our defenders in Ukraine. Thank you very much for watching.
Good night, yeah. Three and a half hours. Damn it, 34 minutes over. That's the extra 10%.